Welcome to this video on the metrics to evaluate the effectiveness of classifier models. After completing this video, you will be able to calculate the accuracy and describe confusion matrix of a machine learning model. In the previous video, you created a machine learning classifier model. How will you check if the machine learning model is effective and useful? And whether the machine learning model is able to learn the patterns from the data and make correct predictions? One of the easiest ways to find out is how many times the predictions made by the ML model were correct. For example, if the ML model is right only 50% of the times, then it is not at all useful. As you can be right 50% of the times by making random decisions too. For instance, the task is to predict the heads in a coin toss. The model can predict heads every time and be right 50% of the time. Since there are only two choices, heads or tails, even a random guess will be right 50% of the time. Therefore, you need the model to be right more than 50% of the times. On the other hand, if the ML model was right 8 out of 10 times, then it is right 80% of the times. And we can say that it is indeed able to find some patterns to map the input to output and not random. In technical jargons, this score of 80% is called accuracy. What should be the desired threshold of the accuracy while using ML models for trading? It is subjective. Is the accuracy score enough to conclude that the ML model is effective? Probably not. Consider an ML model designed to predict whether you should buy or sell. This ML model has an accuracy of 73%. But while using this model, the sell signals are bad and making losses. How is that possible for an ML model with 73% accuracy? To get an answer to that question, you have to get the accuracy number label wise. In this case, you will find the accuracy score for the buy and sell prediction separately. This will help you get a more granular view of how the model is performing. It comes out that the ML model predicted 100 times that the price would go up. The price actually went up 90 times. And 10 times it actually fell. So, for predicting the buy signal, the model is 90% accurate. That's pretty good. The model predicted 50 times that price would go down. The price went down only 20 times. In contrast, it went up 30 times. The model is only 40% accurate in predicting the sell signal. Therefore, placing a sell order based on the model's recommendation is bound to be disastrous. The matrix shown here is called a confusion matrix. Sometimes there are jargons used to explain the matrix labels, such as false positive, true positive, and so on. In the above example, let's say buy is positive and sell is negative. On all the occasions where the ML model predicted buy correctly, we call that as true positive. The number of times where the ML model was wrong in predicting buy, or positive, we call it as false positive. False because the ML model was wrong in forecasting the positive label. Similarly, can you tell what is a true negative and false negative? The number of times ML model correctly predicted negative, or the sell signal is true negative. And where the ML model was incorrect in the prediction of negative label or sell signal, is called a false negative. This usage of terminology of positive and negative comes from medical science, where we run the test and the result is either positive or negative. But in some cases, there can be a misdiagnosis. These are termed as false positives or negatives.